So we know that an exponential function is one that has the variable in the exponent, right? That's the definition of an exponential function, is the variable is in the exponent. Now, you've probably heard stuff with all the pandemic things going on, is that there's an exponential increase or an exponential decrease in the number of cases of COVID or whatever, okay? That word exponential means it's an exponential equation. And those graphs, as we just saw, look like that. This is if b is greater than 1, and they look like this if b is less than 1, correct? Okay. If you hear the words exponential increase, that means it's obviously a growth curve, and it's increasing very fast. That's basically what it means, okay? So when you were talking, the key of when you're going to use these things is usually population increases, bacteria, if they're monitoring populations of a country, or COVID cases, whatever, all right? Those are exponential functions. Now, they don't always look like the type that we're used to seeing. So I don't like the way they write it, so I'm going to rewrite it. We're going to rewrite ours like this. A naught 1 plus or minus the percentage. And I'm going to put t here because that makes more sense when I explain it. That doesn't make sense? You don't even know what I've said yet. I haven't even done anything. Okay, so what do all these symbols mean? T is time, exactly. See, they put time as n. All right, now it could be number of years and stuff, but that, to me, that's still time. So that's why we're going to put t as time. Okay, so the t is equal to time. Oops, go away. So t is equal to time. What do you think percentage equals? Percentage. I would say what does 1 equal, but that's a really good question. It's 1. Okay, this is the important part. A naught and A. Okay, so when I say A naught, all right, that is because in university I had English professors, and that's what they say. So A0, now you don't have to write this down, is pronounced A-N-A-U-G-H-T, naught. It means the initial amount. A0 or A naught is the initial amount. AMT is mine. Can we use AI? Yeah, you can write AI if you want. A1. Or A1 if you want. A naught. A naught. A naught. Why not? I don't know. Why not? Oh, N-A-U-G-H-T. That's like if you say this, 0.04. In English, we would say 0.04. Somebody from England would say not 0.04. That's wrong. But it is 0.04. It's not N-O-T. Anyway, I don't want to get bogged down in the N-A-U-G-H-T versus N-O-T, but I'll say A naught. Just know it means the initial amount. A, just A by itself, is the final amount. Okay? All right. Use this formula when they give you percentages or they ask for percentages. That's when you use this formula. Okay. Yeah. So, in 2016, the population of a university was 160,000 and increasing at an annual rate of 4.5%. So as soon as you see this, 4.5%, you know this is the formula you're going to. Okay? They tell us that we had an initial amount of 160,000. Forget that. And forget that one. Determine the population of the year 2019. Okay. So it's increasing at 4.5% per year. We start with 160,000. So the first thing you need to do is figure out all your symbols. A naught, T, A, and percentage. So what's my initial amount? 160. It's what you start with. What is my percentage? Okay, this is the important part. Yes, it's 4.5, but they say it's increasing at 4.5. If you look back at the formula, it's 1 plus or minus. So if they say increasing, that's going to be plus. If they say decreasing, it's going to be minus. All right, perfect. So positive 4.5%. What's the time? How long? So 2016 to 2019, right? So 3 years. And A is what we're trying to find. So the formula is A is equal to A naught 1 plus the percentage T. Now, when you put the percentage in, it's percentage, you have to convert it to a decimal. So what's 4.5% as a decimal? 0.045 to the power of 3. And then you, yes.
Since 0.045 is negligible, can we exclude it?
Is what, sorry? Is what?
Negligible.
Negligible.
Yeah.
No, because it's not chemistry class.
No.
You got that from chemistry. I know. No, because it will have a, because if I just make this 1, if you ignore that, then it's 1 to the power of 3, which is 1 times the initial amount. So that means that the population didn't increase. You get like 160,000, right? But you're going to see it actually matters. When you're dealing with bigger numbers, that matters. The thing about chemistry is you're dealing with smaller numbers, so it has no effect. I shouldn't say it has no effect. It's negligible. All right. So we follow bed mass, 160,000. What? Dante, if I was speaking Italian, I would butcher words more than that. So. 17.
Which one?
No, I speak 1. And I know a little bit of Italian. I took French in high school, but I don't remember any of that stuff. I speak math. Is math a language? People say it is. They say it's a language, so I don't know. Anyway, 1.045 to the power of 3 times 160 grand is, anybody? 182,587.
Did it in your mind?
Yeah.
Really?
No.
Oh.
I have the answers right here. Okay, so that's it. Does that make sense? It's figuring out all the numbers, plugging them in the formula, spits out the answer. In 3 years, the population, if it continues at the same rate, would be 182,587. Okay? All right. A better question is, if the population continues to grow at this rate, determine the number of years to the nearest year for the population to double. Okay. So there's 2 ways to do this one.
Okay. Now you are finding the exponential.
There's our formula. Okay, so it's increasing still. So we know that our percentage is plus 4.5. Time is what we're trying to figure out. How long for it to double? Now here's the 2 ways to do it. What is the initial amount? 160,000. What's the final amount? Oh. 2 times that, which is 320. Okay, you can do it that way. and you plug those numbers in. So I'm going to get 320,000.
So you know that the bracket has to be true.
1 plus.
You can joke with my English, not with my math.
I wasn't even joking with your English.
No, it's personally.
All right. How do I solve this? What's my first step? Divide by 160 grand. What's 320 divided by 160?
Really?
Okay. So we get to this point. Our unknown is an exponent. How do you bring exponents down? Log it. Now, what's the two cases that you want to use, or two logs that you want to use if you're going to log it? Natural log or log? Which one do you want to do? I heard natural log, so I'm going with natural log. If I natural log this side, the t falls down. Then what do I do to solve for t? Yeah. This is a number. Natural log of whatever. I mean, you can convert it to a number, but that's just a number. So I'm going to divide that off. So if you divide the natural log of 2 by the natural log of 1.045, you get 17. 15.575 years. Rounded to the nearest would be 16. Is that just a pure guess? All right. Is that okay? Now, you don't have to write this down, but here's the other way to do it, because you will get questions that don't give you the initial amount. So, okay. If you don't want to do it this way, or they don't give you the initial or the final amount, you can still do it if they say, how long does it take to double or whatever, because the initial amount, we can just say, okay, we don't know it. It's A naught. Who cares? But the final amount is what? It's 2 times A naught. That's what you did here. That's how you got that number, right? 2 times 160. And then times what we're trying to find, and this is 4.5%. So when you plug it into the formula, you get 2 A naught. That's what goes in for A. A naught or A0 or A initial, whatever you want to call it. 1.045 to the T. What happens to these A naughts or A zeros or A initials? Well, you're going to divide them off, right? Because that's what you did here. You divided by 160 grand. So when I divide off the A naught, you get 2 is equal to, they disappear and you get 2 is equal to whatever, which is that formula there. Okay? So you don't actually need to know the initial amount. I can just say, here's the rate that it increases or decreases at. How long does it take to triple or double or anything like that? And you can still solve the question. Okay?
So that number that we got in the first part in blue has nothing to do with this part.
Well, you're going to get the same number, right? Because this equation is the same as this equation. Yeah, are you talking about this part, the red?
No, the blue up there in the box.
Yeah. That's how long it takes to double.
No, wrong box.
What?
In the blue.
This one?
Yes.
Oh, that's just saying that's a different question. No, it's saying what would the population be in 2019?
So if this is double, just double that number. If this is triple, just triple it.
Exactly.
You got it.
All right. Next page, please. All right. Number of fish in a lake decreased by 5% each year. We're not doing that. We're not doing that. All right. We're going to do C. Shh. So we decreased by 5%. As soon as you see a percentage, your formula is, this is the general, but we're decreasing. So is it going to be plus or minus? So that's going to be our general formula. You just need to figure out what numbers we need or go in there. So C, they tell us there's 2,500 fish present in 2019. How many should be there in 2024? So A is what we're trying to figure out. A naught, the initial amount is 2,500. What's the time? 5 years. And the percentage, what was the percentage? 5%? Does that make sense, that formula? Because we're decreasing, right? So it's 1 minus 0.05%. So I get 1 minus 0.05 is 0.9, or is 0.95. Time is actually 5 years. I can put that in. So if you punch all that in, you get 1934. 1934. Is that what we got?
Since they're 5 years, it's decreasing by 5% every year. It's decreasing by 5% of the initial amount or 5% of the new amount every year?
Of the new amount every year.
Oh. Yeah, so they can never be zero.
Well, that's the whole half-life argument, right? I mean, eventually it does go to zero, but it's like half of a half of a half. So theoretically, it never goes to zero, but obviously it does.
It's like half a fish. I don't think they can be possible.
I know. All right. Because it's 1 minus 0.05, because it's going down, right? Yeah. All right, D. How many years to the nearest 10th for the fish population to reduce to half of the number in June? So we don't know the initial. Do we know the initial? Oh, we do. But let's pretend that we don't. If I say percentage. Okay, we know percentage is going down, so it's minus 4.5. No, 5 minus 5. The initial amount, just pretend that we don't know it. We'll just call it A naught. If I say, how long does it take for it to reduce to half of that amount? What is A? Half A naught. And time is what we're trying to find. So when you put it into the formula, you get that. Yeah, I will. I just didn't do it yet. Do you want me to do that?
I don't know.
I'm going to do it in the next step. What happens to the A naughts? You're going to divide them off, so they're just going to go away. So you end up with that. 0.095t. What do? We have an unknown that is an exponent. What do? You want to do natural log? How about we do both? You can go... Or you could do... You can do either one. And the answer either way is 13.51 or 13.5 years. They went to the nearest tenth. That's 1 decimal. Tenth of a decimal, 0.1 decimal place. So I should have written 13.5. All right. Is that okay? What about this last one? 3. The intensity of a light source is reduced to blah, blah, blah when it goes through d meters of a fog by the formula I is equal to I naught e to the negative 0.12 d. At what distance to the nearest hundredth of a meter will the intensity be reduced to 1/4 of its original value? Now, they give you the formula. So you don't have to come up with a formula. They give you the formula. What is I0? That's A naught, right? It's the initial amount, right? They want to know at what distance, so you're trying to solve for D, will the intensity be reduced to 1/4 of its original value? So if I say 1/4 of its original, what is I? There you go. Then just plug it all in the formula. Now, the I naughts will go away, correct? As soon as you see the letter E, what is it screaming at you to use? Natural log. When you natural log the letter E, what happens to all that right-hand side? Dies? It's just the exponent, right? Because remember, natural log is log base E. So really, it's just natural log of 1/4 is equal to negative 0.12 D. What's D? Divide off the negative 0.12.
But D is negative?
No, D will be positive. Because the log of 1/4 is negative, right? So the distance is 11.55 meters. All right? Because natural log is log base E, so this is like log base E of E to this. And the base is matched, so it's just the exponent. That's why. I mean, you could do base 10, but you're going to have to punch log base E into your calculator. So, or log E into your calculator.
How are we supposed to know that it's that?
Sorry, because that's the only E there is in math.
Then Buck used the same variables for like 5 different.
No.
Yeah, what if
In math, if you see this E, it means 2.718, blah, 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 blah. What?
What is it called again? It's just called E.
Yeah. Sometimes it's called Euler's number, Euler's number, sorry. But you spell his name like this. Euler. E-U-R-M. Yeah, whatever. Doesn't matter. Anyway, 1 to 7. You're not going to get them all done because I'm only giving you 7 minutes because we have a second part to do today.
This is terrible.
I will have lots of practice at the beginning of class of this tomorrow, okay? So there is another formula. So we have this formula. I mean, they are essentially the same formula. We have this. 1 plus or minus the percentage time, okay? This is if you have percentage. If they tell you a percentage in the question, that is the formula you're going to. 99% of the time in this class, 100% of the time, okay? It'll be that simple. Now, obviously, there's more complex stuff, but for us, that's what we're going to do. However, they don't always tell you the percentage. They'll say how long it takes for it, or they tell you the doubling time. They don't say it increases by a percentage of whatever. They'll say it doubles every 5 years, or it triples every 5 years, or it has a half-life of this. That's a slightly different formula. And I hate the way they write it. I just don't like the way they write it, so we're going to write it like this. And I will give you both these formulas. I'll write them on the board. I'll put them on your test, okay? I don't care about you memorizing these formulas. I care about you knowing how to use the formulas, okay? So, A is equal to A naught C to the T over P.
Thanks, there was also upset.
What?
There was intermediate stuff.
Oh, yeah. Whatever. What was I gonna? There was something I changed about it. I don't know. Anyway, doesn't matter. It is the same. You're right. It is the exact same. There was a. Yeah, you have to write them at a slight angle. I wrote them at a slight angle. My font is better. Okay. So A naught is what we've already talked about. It's the initial amount. Use a highlighter here. Initial amount. A is the amount at time t, which is really just the final amount, which we've already talked about. T is time. We'll come back to C in a sec. And P is the time to double or triple or whatever. Okay? These two, this is the trick. These two must be in the same units. So for example, you can't have your time in years and the time it takes to double or triple in minutes. That doesn't make any sense. Because they're being divided here, the units have to cancel. So they need to be in the same years. You can't have an exponent that has units. All right, it has to just be a number. Okay, now C. C is the base. We know it's the base because it's tied to the exponent, right? All C is there'll be a clue in the question, and it'll say it takes this long for it to double. If they say double, C is 2. If they say triple, C is 3. If they say half-life, C is half. If they say time it takes for it to quadruple, what's C? 4. Exactly. Okay? So, these are more science-based questions because it's a lot of, well, if you take microbiology and those type of things, it's a lot of bacteria stuff. So, we have a patient feeling ill, blah, 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 sample. The initial sample has 387 cells. 24 hours later, the sample was recounted and had 8,012. What is the doubling period? Okay, you see the word doubling. What does that mean? C is equal to 2. So these are all our unknowns. A naught, C, T, and P. So C is 2 because of doubling. What is A naught? 387. So what's 8,012? A, it's the final amount, right?
Come on, guys.
All right. What is 24 hours, T or P? It's T, right? This is where people will get it wrong, okay? They will mess up the T and the P. T is the time, is like the time of the experiment. So in this case, 24 hours. P is the time it takes to double or triple or the half-life, okay? So this is what we're trying to find.
No, sorry. What is the difference between P and P?
T is the actual time of the experiment. How long the experiment took. Okay?
And P?
P is it's tied to the doubling time or the tripling time. So if I say the doubling time is 3 days, P is 3. If I say the half-life of a substance is 4 hours, P is 4.
But we got an experiment of 24 hours. Not
No, 24 hours later, right? That's how long the experiment took.
and, so we want to know
What is the doubling period? How long does it take for the bacteria to double? Okay, so we,
maybe after 24 hours it was like 1600.
yeah.
Okay, got it.
So we plug everything into our formula. So we're there. What do I do? What's my first step to solve for P? Get rid of the 387. Which is 20.70. So now I have 20.70 is equal to 2 to the power of 24 over P. Our unknown is an exponent, so what do we need to do? Log. It doesn't matter what log you use. I'm going to use log 10.
Why not get enough P?
You can do natural log if you want. It'll give you the same answer. I'm trying to solve for P. How do I get P by itself? Multiply it up here. And then divide by log 20.7. And if you punch that in your calculator, you will get 5.5 hours. 24 times log 2. Is that okay?
You got 5.5 hours.
Yeah.
That's not what I got.
You did it wrong. What's log 2? What's natural log of 2? Times 24.
It's 8.
Oh, the whole top's 8? The whole top is 8?
7.2.
So the whole top is 7.2.
Yeah.
Okay. What's log of 20.7?
Oh, that's 20.7, not 2.7. Oh, okay, got you.
All right.
My fault.
All right. One more question, people. In 1996, Chernobyl contaminated the atmosphere, radioactive iodine. Half-life is 8.1 days. So here's all the stuff we have to find. We have A, we got A naught, we got T, we got P, and we got C. We're talking about half-life. So what is C? Half. I tell you the half-life is 8.1 days. What number is that? P. Determine the number of days to the nearest day it took for the level of radiation to reduce to 2% of the original level. So they don't give us the original. They want to know how long it took to go to 2%. So what is A? 0.02 of A naught, right? The initial. So A is 0.02 of A naught. That's 2% A naught. Right? Remember in math, of means multiply, right? Remember hearing that at some point? Of? That means multiply. So A naught is still A naught, and we're trying to find T. So there's your formula. What happens to the A naughts? Unknown is an exponent. What do you have to do? Log it. How do you solve for T? Should be about 46 days if you put it in your calculator. You are going to have a question like these on your test. Okay? All right. You should finish the whole thing. This one, log 1/2. I divided that off. Oh, sorry. It's 1/2. Sorry. 0.5.